Welcome at the TU Delft. This is a place where tomorrow's innovations are being developed. Now, making such an innovation a success, it's not an easy task. And oftentimes, the technology itself is not even the hardest part. In order to illustrate the difficulties that they face every single day, let's take you on an innovation journey of a material called glare. In order to start this journey, let's take it back to the 50s, when glare was first developed. After World War II, a new era of planes began. These planes utilized jet engines and sheet aluminium bonded together with metal. However, early on in development, 2 of these planes crashed. And after extensive research, metal fatigue was defined as the problem. Well, in this case, the problem itself was clearly structural, but was it also easy to solve? Simply strengthening the construction was not an option, as a heavier plane uses more fuel and thus implies higher costs, which is unacceptable in most cases. The use of new materials might solve the problem. In the 70s, Fokker and Delft started experimenting with fiber metal laminates. Initial test results were not promising. Fokker employees actually recommended pulling the plug on the project. Apparently, at the time at Fokker, the dominant logic was that if initial test results did not seem promising, the whole project was doomed to fail. Luckily, TU Delft professors thought differently and thought the material could be improved. Luckily, some people within Fokker also continued the development of this project, not following the organizational routine. Eventually, their hard work combined with the TU Delft resulted in the creation of a new material called Arall. Now, this team soon realized they were lacking the core capabilities in order to further develop this material. Therefore, industry partners were contacted. Unfortunately, Fokker, the ideal partner for this project, was still not interested. Now, luckily, AXO added the necessary material knowledge and a research lab to the table. Now, likewise, 3M was involved for the expertise in adhesives. Now, these partners helped to develop Arall even further. And this time around, test results were actually pretty positive. Unfortunately, Fokker still would not use the material in their planes. Arall simply hadn't become the breakthrough innovation everyone had hoped for. Now, the main reason for this were the high costs involved with the material. However, another big challenge is the fact that airplane manufacturers usually only look at investing in new materials when building a new type of model. However, most planes are simply an update of the previous model. Now, the TU Delft did not give up. They shifted focus to a different type of FML, called glare, this one utilizing glass fibers. Now, getting glare accepted in the airplane industry was still a big challenge, as they needed to change conversations within this industry and actually make the airplane builders consider using glare for new models. Another invention, called splicing, also helped to make glare more cheaper and thus more interesting for the industry. Finally, aircraft manufacturers started showing interest in glare, but it was eventually Airbus who signed a contract in 2001 to start using it in their airplanes. A manufacturing plant was built by Fokker, and eventually in 2005, the first flight took place. Nowadays, 350 square meters of glare is used in every A380, the biggest plane in the world. This case illustrates that a change in conversations is crucial to adopt a new innovative material, not only towards the market, but also within the organization and between partners. After all, this fight against fatigue appeared to be much more than purely a technological battle. It was a fight against inertia and against resistance.